And welcome back as we go ahead and continue our exploration of astronomy. Previously we had looked at light years and used that as a measurement, but what is the consequence of using light as our travel buddy here? Well, let's go wind this conversation back a little bit to talking about the speed of light itself. The speed of light for astronomers is a natural unit of distance. Again, it's how far light can travel in a year is a light year. And it's very common to use that to measure these vast distances of space. Now, information about the universe comes to us almost exclusively through various forms of light, whether it's infrared, ultraviolet, visible light, X-ray, gamma, etc. And all such light travels, regardless of what kind it is, at 1 light year every year. Its speed is the same regardless of form. Now this does set a limit on how quickly we can learn about events in the universe. So for example, if we say a star is 100 light years away, the light we see from it left that star 100 years ago and is just now arriving to us. If we had a star, let's say that was 1,000 years away, then obviously it's 1,000 light years away, so on and so forth. So the soonest that we can learn about any changes that happen in the universe relative to a star is, let's say, 100 years after the fact or 1,000 years after the fact. Whatever speed that light had originally came from is going to be how fast we can receive that information. So it does put a bit of a barrier on how quickly can we learn things. However, can we use that delay, that slow response of light getting to us, to actually learn anything? Well, there's no way for us to know anything about the star or any other object in the universe until its light reaches us here on Earth. Now, this might seem like a great frustration because, I want to know this information, I want to know now, but it's actually a tremendous benefit in disguise. So, if astronomers really want to kind of piece together what has happened in the universe since its very beginning, they kind of have to find evidence about each time period. So, if they want to look back at all the way back to the beginning of time as far as we can look and various time periods in between, we're going to actually kind of want to have a delay, because if we had all the information at once, that information previous to the information we have now, we would never know it. So where can we actually find evidence today about cosmic events that might have occurred billions of years ago? Well, the delay in the arrival of light actually is going to provide us an answer to this question. So we're going to use this delay to actually help us reconstruct the past. So the farther out in space we look, so deeper into the cosmos we go, the longer the light has taken to get to here, to us on Earth, and the longer ago it left its place of origin. So by looking billions of light years into space, astronomers are actually seeing billions of light years, or billions of years, into the past. In this way, we can reconstruct the history of the cosmos and get a sense of how it has really kind of evolved over time. Now, obviously, we can't just take our eyeballs and look up the sky and figure it out. We actually need to use some tools to kind of help us with that. And this is one of the main reasons why astronomers are always striving to build bigger and better telescopes that can collect more and more of that faint light that's in the universe. And the more light we kind of collect, the fainter the objects we can observe. Now, on average, those fainter objects are typically going to be farther away and can therefore tell us about periods of time that are even deeper into the cosmic past. Now, of course, we have a bunch of wonderful instruments that can help us with this, such as the Hubble Space Telescope, the Very Large Telescope in Chile, and of course the more recent James Webb Telescope, which all help astronomers get views of deep space and deep time as well, because remember, space and time are connected. And it allows us to do this even better than anything we've done before. And we're always constantly trying to peer deeper and deeper in the cosmos and then interpret that information that we observe.